I'm a techie and obviously think that this particular project and some of the other things that we're working on are interesting from that perspective. I think a more interesting conversation is how other applications, how other work can duplicate some of the successes that we've had. I think that it's pretty obvious that Congress isn't real happy with the progress or the lack of progress that VA has made in recent years. And I think part of why it's interesting is because we have sort of a unique situation here with VistA. There's a really big community around VistA, obviously. We have OSEHRA and World VistA, and a lot of other people that are just kind of out there on the fringes, doing lots of really great work every day. And I think that there is a lot of power in that. I think that there is the potential to steer the ship generally in the right direction, and hopefully prevent what I personally don't think is the best choice, at least not now and not for the foreseeable future, which is VA just decides to extricate VistA from the VA and replace it with some commercial offering. I think that would be bad for patient care. I don't think that that's real practical from a technical perspective. I think that it would be a lot of wasted effort and money, and I hope that things don't go that way. So I guess as I'm going along, maybe just sort of keep that in the back of your mind, and I'll go ahead and move on. So VistScopic has been around for just a few years now. We were founded primarily for some of the work that we're doing with the VA's Public Health Surveillance and Research Office. They needed some help with the PACE program, and so that was one of the first projects that we really went full speed ahead on after the company started. I left VA to go and work for VistScopic. Before that, as was mentioned, I worked for VA for a number of years. Probably the work that I did there that most people on this call will be familiar with is Meadows. I was the Meadows lead developer for a number of years, integrated a number of apps with VistA via Meadows and earlier predecessors to that technology, and had a lot of success with that. So Project Hilleman in particular is kind of an evolution of some of those principles, using web services, refactoring VistA, hiding the business rules, having a high degree of reusability, things like that. So we at VistScopic are, we kind of dabble in VistA. I'm not necessarily a proficient MOPS developer. I can kind of figure it out. But like I said, I kind of work out there on the fringes. I'm primarily interested in enabling technologies. We're also big data specialists. We do some NLP and machine learning stuff, and also UI development. We have several apps in production VistA today. Not that that's the sole indicator that the technology choices that you're making are the right ones, but it's usually a decent one, so maybe it's worth mentioning. Again, I think that what enables us to be successful are those technology choices, that architecture, and the infrastructure. That's always a big focus of ours whenever we develop some new capability. So Hilleman is, at a real high level, it is web services for VistA data. It's also kind of a little more abstractly sets out to define some really rough guidelines for refactoring legacy VistA code, exposing that new functionality as web services, making them reusable. The analogy, which isn't perfect, but the best one I have, is if you were going to write a new application for a SQL database, you wouldn't write it all probably in stored procedures. You'd use some other higher level language. And I think for the most part, that's kind of what we're stuck with VistA. It's really server heavy. It's difficult to figure out what the interaction between all the different packages are. There's just a whole lot to bite off there when you want to develop some type of new capability. The business rules aren't documented really well. If you want to figure out why some data gets written to some place in VistA or doesn't, you pretty much have to trace through the MUMPS code. And not very many people can do that. So, anytime you want to integrate a COTS application with VistA or develop, some new software, some new piece of functionality, it's slow, it's really costly, it requires a really high level of technical expertise and system knowledge. So the goals of Hilleman, as grandiose as they sound, are to maybe not completely solve, but at least lessen some of those burdens, make it easier to integrate COTS application vis-a-vis web services, make it faster to develop new capabilities, et cetera, et cetera. All of those things that are good, that's where we want to move toward. So the way that we do this is, like I said earlier, you wouldn't write an app that sat on a SQL database and stored procedures. You would decouple the data from the business rules, from that sort of design level. The APIs, of course, need to be really, really fast. One of the strengths of VistA, of course, is because of the way the database is structured. When you do things in MUMPS code, you have pretty much direct access to the database, and those operations are really, really, really fast. So performance is, of course, a big consideration when you're moving away from that architecture. Even though the Hilleman in particular, this is probably getting down in the weeds a little bit, but it's okay. We'll come back out soon. The flexibility to get close to the metal, and by that I mean do those low-level operations when you absolutely need to, but try to stick to higher level, but still generic APIs when at all possible. And that'll probably make a little more sense shortly. Ability to work with all business system types. So, I'm not talking about any cache development or anything like that. The way that we go in and get data from VistA for Hilleman is through the FileMan APIs. Support every language technology possible. This is just kind of a given when you have web services. It's sort of a freebie. Pretty much everything out there can talk to web services these days, even the browser, without too much effort. So, that's just, like I said, sort of a freebie there. And then evolution, not revolution. Like I alluded to earlier, I don't think that revolutions typically go as smoothly as the people that are pulling the strings think they should. I think that there is a lot of merit in evolving things. So a big tenet of the way that I refactor and design new APIs is that I don't break any pre-existing functionality. So for example, one of the applications that we developed as a proof of concept is a scheduling application. So it interacts with the scheduling package and pulls appointments out of VistA, actually allows you to write appointment information back to VistA as well. all following, all the same business rules, adhering to, user rights for scheduling in a particular clinic and things like that. It doesn't break any existing functionality. So if you make an appointment using my refactored M code and my Hilleman web services, and then you go into the roll and scroll, you can see that exact same appointment. It doesn't look any different. So that's what I mean by evolution. So at a real high level, what this looks like, of course, we have VistA databases. I have a bunch of VistA databases here because, that's the VA topology, which I work in most of the time. And then you have CPRS that sits on top of it. This is the state of things as they exist for the most part today. And that's it, this two-tier architecture where there's no real separation of concerns. You have a really thick client, a really thick database, and they send messages back and forth across the network. It's not really great for reusability. It just kind of is what it is. So instead of that, what I settled on, the design I settled on for Hilleman was using FileMan for CRUD APIs. So going to the FileMan file structures and grabbing data that way. So using APIs like if we're using the RPC broker, DDR lister, DDR gets entry data, DDR filer. We have a couple different ways of communicating with the database. One of the other capabilities that we developed actually uses Node and some JavaScript libraries to call these FileMan APIs directly. So lists /dic and gets /diq and those APIs, but they're essentially equivalent. There's just an RPC wrapper around them. But anyways, using those APIs to read and write from essentially anywhere in VistA. And earlier, I briefly mentioned the capability to get closer to the metal. Of course, FileMan isn't always, not everything is mapped to FileMan. Lab data, for example, because it's such an old package, there's still data in those globals that you can't get to via FileMan. You have to do direct global operations to get at that stuff. Not completely abandoning the ability to do that. There are some features in here to perform those types of operations as well. Anyways, on top of that, we have refactored / translated business rules. So basically, I have just been going through the different domains that I find interesting. One of the first ones that we started with was scheduling. The mass project was going on kind of at the same time that we were getting this whole project spun up. And so we felt like that would be a good candidate to start with. It's a pretty tough one. There is quite a bit of business rules for that data. So, it was a good exercise of all of the technology choices, but also meaningful at the same time. I've also done some stuff with patient demographics and user management as well, allocating, security keys and menu options and managing users in VistA, stuff like that. So the evolution is just pretty much going through these packages one by one and refactoring and translating the legacy mumps code into Hilleman is, I don't think I mentioned it yet. It's currently implemented in C#. There's nothing special about C#. I just happen to be a .NET developer, so primarily a .NET developer. So that was an easy technology choice for me to make. But going through the code and one by one, refactoring it to C# code that can then be wrapped in web services. So the services that we have right now are both REST and SOAP. Mostly REST that I'm working with just because it's lighter weight. And there are some new capabilities that have come in the last few years that make those a little more self-descriptive and give you some of the advantages of SOAP web services without the extra performance requirements that having a SOAP web service involves. Anyways, a fairly simple stack here. Then on top of that, we just have our bucket of functions. So these are all obviously REST APIs. They are meant to be, meaningful. That's part of what REST is all about. So you can probably figure out exactly what's going on here just by looking at operation names themselves and URIs that are involved there. And then on that, we've written some applications to, just kind of, like I said, a proof concept to prove out the whole stack work. So this is a screenshot from a really early version of an app that I wrote that I called Chronos that lets you look at clinic availability information on top of each other, which is a capability that doesn't exist in VistA today. But is powered by these new APIs. But the API, the application itself, the UI can really be anything. Once you have these web services, because the APIs don't change, it becomes much easier to yank out one API and stick in a new one. Actually, when we were kind of getting involved in the Mass project, I purposely waited to the last minute to try and integrate an application with my services, just to prove that I could. So while I was waiting in the airport, getting ready to fly to DC to go present some stuff, I went and I downloaded some open source calendar application, and in a matter of 20-30 minutes had appointment information displaying in this essentially open source free calendar UI. Because all of that work had been done, all of the really heavy time-consuming infrastructure refactoring work had been done. Like I said, tossing out one UI and replacing it with another becomes much more straightforward. There's my cheesy anything graphic. Again, it doesn't really matter what the UI is. This is a more recent version. We actually recently plugged some of these services into production VistA inside VA for some other projects that we're working on. But we thought it would be interesting to see if the scheduling application, the scheduling services work. These are obviously read-only, but we were able to go without any changes to the code at all and get appointment information from production VistA site and display it, in the UI without changing really anything at all. And that's what this is. This is just a screenshot from a little bit nicer looking version of the calendar app that I showed in the previous screen. And this is that same user interface again, just slightly revamped appointment information inline. You can click on these and actually schedule an appointment in these time slots. There's a patient search widget in there, so you can find your patient, you can see the patient's other appointments, all that sort of stuff that you might be interested in. Not a completely finished, ready to sell application, ready to use application, but again, just a proof of concept shows that everything works. This UI, there's actually an interface similar to this inside of the terminal interface, the roll and scroll, where you can look at a single clinic's availability for a date range. This is obviously a little more interactive. You can actually click. These are supposed to be hyperlinks, those blue ones in this grid here. But similar to the last screen, but just for a single clinic. So again, the point is a low-cost architecture, high degree of extensibility. It's more supportable because things are decoupled. Modern software development business practices. It's rewritten in a language that more people understand, et cetera, et cetera. Because the emphasis is on good APIs. Like I said, it's easy to integrate. new applications, Kafka products, whatever it is that you want with these services. Because the infrastructure is flexible, it's also much easier to support new types of technologies as well. Like I mentioned earlier, by using web services, for example, you pretty much support everything out there. You can do mobile apps much more easily when you have a web service to consume in that mobile app. It's much quicker exercise to prototype things. Instead of going through this really long development process where you write new months code and you go through all of the steps of getting it certified and actually deployed to a place where there's some interesting data. A process that can take months and years in some cases. You can do that much more rapidly because you are not relying on all of those old ways of doing things. There's a big resource in VA in particular. We have a lot of doctors. Doctors are nerds. A lot of them dabble in technology, are interested in software, and like to do some type of development, or at least have a hand in it. But because of the high level of technical expertise, they just don't have time to figure out exactly what VistA is, all the different ways that you can interact with it. So giving them a set of tools that they can use to do similar types of development and develop their own innovations. I think that's a big untapped resource that these type of technologies enable. Again, it's really supposed to be non-disruptive. Doesn't break current business practices. It just sort of inherently provides a path to modernization. When you evolve things, when you don't just turn one thing off and turn another thing on, once you've finished developing that thing that you have evolved to, your work is done. You can migrate people to that, and you don't have to just take applications, take functionality away from people. Once you've done all of that work, you're just, you're there. You're working towards the end game the entire time without breaking all of those current business requirements. Again, using industry best practices, web services, separation of concerns, et cetera, et cetera. So that is pretty much it for Hilleman. I wanted to also highlight a couple other applications that we have in VA today. Predico is in production in VistA. It's completely national. It is a biosurveillance user interface. Basically, I'll show some screenshots in the next couple slides. But users can use this to generate reports. Look at trends, hospital-acquired infections, influenza, antimicrobial susceptibility, those types of biosurveillance user activities. So we have some infrastructure that we've developed that pulls data from all production VA VistA systems a couple times a day, cleanses it, puts it in a data warehouse, a big data warehouse, and then this Predico application provides visualizations and query capabilities for doing the types of things that the users need to do with that data. So these are some screenshots of that. The screenshot on the left is kind of, I apologize, I know it's a little scrunched up, but that's essentially the landing page when the user first comes into the Predico app. There's a map where you can zoom in and out and drill down on facilities and so for whatever data it is that you're interested in, you can. So there happens to be some antimicrobial search criteria over in the search filters section on the or screenshot on the right there. So if that's what you were looking at, of course you could, you know, the rest of this information would be relevant to those search filters. You can see right below that there is a time series graph where you can see things over you know, a period of time. And then there's also some capability to group the criteria. So you know, you can select age ranges, you know, by facility, by state, stuff like that, and then look at that data differently. And then that heavily redacted section at the bottom actually shows some patient information and facility information, you know, in a tabular format. And the users can export that to you know, like a CSV file, Excel, stuff like that, if they want to do something else with it. The search filters is just what it sounds like, you know, for the different types of queries that the users may want to perform in Predico. You know, this gives them the capability to do that. So there's a huge amount of flexibility here with the types of filters that can be applied to a particular search. This is a little bit better screenshot at the top of the time series graph. So again, you have the capability to group the time series graph and the other visualizations by facility, by you know, patient gender, age group, and things like that. You can get counts, mins, maxes, etc. So I guess you know, just to reiterate right here, this application doesn't necessarily have anything to do with Hilleman in particular, but you know, going back to some of my points at the beginning, you know, the ability to build applications like this that sit on top of not necessarily VistA, but data that has been derived from VistA are possible in large part because of you know, some of the design decisions that we've made, those architectural choices. So you know, even for things that might not necessarily interact directly with the VistA system, still obviously very important. At the bottom, back to the slides, some saved searches, so just more screenshots. This is kind of an interesting capability that Predico has. You can configure alerts and get alerts and look at the detail for alerts. So the system will actually, you know, it develops a baseline, you know, for counts and things like that. And when it detects anomalies, then you can configure alerts for those, you know, or at the very least, you know, using these interfaces, kind of drill down and figure out, you know, exactly what's going on there. So that's kind of cool. These are just CAN reports that have been defined. Another screenshot from that, an antimicrobial susceptibility report. Another app that we have in production is Predigene. This one actually is a client of those Hilleman services. The way that it integrates with VistA is for patient information and lab information. So we pull patient demographic data, lab information, you know, stuff like that. But what it is it's a hepatitis C genomic resistance testing reporting workflow tool. So hepatitis C treatments are really costly. They're pretty nasty. And the treatments that are available, there is genetic tests that you can do to see whether or not this patient's particular strain will even respond to the drug treatment options that are available. And you know, those tests are much less than the actual treatment themselves. I think the treatment is on the order of like $80,000 and up, whereas you can perform these genetic tests for a couple $100 and see exactly which treatment options this patient will even respond to. So we built a number of tools for that. We automated all of. This is another piece of software that we're actually going to be rolling out to other labs as well for other types of genomic testing, genomic resistance testing. But we developed specifically for the PHSR office. They were doing this manually. They're building the reports manually, looking at the sequences manually in a tool called Genius. There was just a whole lot of manual steps that were involved in this. So we went in and we automated all of the stuff that we could automate, added quality control checks and things like that. And then we built the reports for them. So what was taking them roughly, I think they said a half an hour if there were no issues for a single report, now they can do in a couple seconds. And their workload has just exploded since this test became available. I think that just about all VA sites, I think that this is the only facility, they're the only lab that does this test in VA, as far as I know. So everybody that knows about it, that's going to prescribe some type of hepatitis C treatment, sends the patient specimens to PHRL, is the name of the laboratory, Palo Alto Health Reference Laboratory, for these tests. So their workflow has gone up like crazy over the last couple of years, and just the reporting aspect itself was taking up a huge amount of time. So we went in and worked on that for them. We're also working through the requirements for an enterprise level results reporting. So now, you'll see it on the next page, here's a sample report. These get emailed around. This is the output in a PDF. And sometimes the requesting facility will enter this information back into VistA. More often than not, I think they just scan it in as a PDF into VistA somewhere, and it just becomes a note, and it's not really computable data. So we are working through some of the requirements surrounding how we can send that information, the results from all of that genetic testing back directly to that VistA system, and file it there, and all that good stuff. I think that's much it. So that's the end. I think I'm a little bit early. Did we have any questions? I can't see them if we did.
Okay, well, thank you, Joel. If you have questions, just go ahead and place them into the chat feature, and we will read them out loud here. Or you can also, like I said, raise your hand, and we'll be able to unmute you to answer.
Sure.
Or to ask
I know Jack already asked. Jack Taylor, I just unmute you. You can go ahead and ask the questions.
This is for Joel. I had a couple of questions, which are, number one, I wanted to comment saying great presentation. Number two, I didn't know if you had any additional details relative to the access to the broad data that's within the VA, how that was accomplished in order for you to do some of the work that you're doing in Prideco and in the Prodigene work. I just didn't know how many hoops you had to jump through in order to get administrated in, because we haven't seen you, let me put it that way, through the code in flight incorporation of what are extensive capabilities. Very complex question, but I'm a damn doctor.
I think it's probably a complex answer too. The HACE program, I don't even know if it's still called that, to tell you the truth. What HACE stands for, by the way, is Healthcare Associated Infection and Influenza Surveillance System. They do a lot more than that, so that's why I don't know if that's necessarily the correct term for the program anymore. But it's an easy acronym, so I'll just continue to use it even though it's probably incorrect. I apologize. But anyways, so the HACE program has been around for quite a long time now. It's always been kind of run out of Palo Alto. They've had, obviously, when they were first starting, a lot of problems getting, just that type of access that you're asking about. Let alone, the technical aspects of exactly how you connect to a VistA system, how you make an efficient system where you can pull data out of a production VistA system without impacting users that are on the system, CRS users and local users and all that sort of stuff. And so it's been kind of an evolution over the years. I got hooked up with that office in, I think it was around 2011-ish, and it actually kind of an early predecessor to the technology that they have. We developed for some people on this call might be somewhat familiar with it, Aviva, which was supposed to be a lot of these same concepts actually. So web services and data repositories, so that you could do decision support and interesting things like that. So it was this big architecture basically. I wrote an early version of the software that the extraction software that we have today is based on, and provided it to the contractors for PHSR at the time, because it was a VA employee, to use and go and pull data from VistA. So I wasn't really involved with it when they got all of those approvals, when they were going through that process. So I'm not sure exactly how much of an issue it was back then. All of that was already in place.
With the current excitement, let me say, over, you already mentioned about 3 hot topics. There's the genomics as a big ticket item. There's the Zika virus as a small ticket item, but it may start spreading through other populations. There's going to be a lot of interest into the ability to access information or to actually posit queries appropriate to the information that may be needed, that you and your team may have worked on. So that was all kind of question 1. And I'll defer to the host or Peter Lee if I could ask question 2.
You go ahead, Jack. No, we have enough time.
Yeah, the question 2 aspect is that as OSEHRA, and I'm the co-chair with Peter Lee of the OSEHRA Architecture Work Group. Thank you, Peter, and OSEHRA. There's a lot of interest in how much of what you've produced, which is respectable and to some aspects awe-inspiring, is actually being submitted through the code in flight processes of OSEHRA, in addition to being made available in the presentation today, et cetera. So
we've never, so as a VistScopic employee, I've not submitted any code through the code in flight program. We have released some of this, the Predico stack as open source. The Predico application itself, the user interface, that's just kind of like a COTS product, I think. I think is the way that we treat it. So I don't know that that Bitscopic is going to release any of that, but the rest of it is open source. We can definitely discuss that. I think that we would all be happy on my side to have that conversation, figure out what we need to do there. I think it's pretty simple. I think we could just kind of, give you a package and
yeah,
you can
it's pretty simple, but there is a process. If you haven't commenced on the process, and Peter is much more wise than I am about this, I would at least suggest it, because you can still restrict or have redacted proprietary stuff that you guys have absolutely done on your own or productized. But getting things into the queue is going to become important, both to OSEHRA and to the VA, as they try to actually increase their absorption of open source, creatively tested and proven code that actually works to the needs of the functional users. And that's who I represent in OSEHRA, is the functional users. Like I said, I'm just a damn doc.
Mm-hmm. Yeah, we will. I'll reach out to you and the other people that I know in OSEHRA, and we'll. Like I said, I don't think that that anybody on my side, because like I said, we've already put code out there, just in GitHub as an open source project. So I don't see any problem on our side with releasing it through the code and play thing as well. I apologize. I think that it sounded to me like your first comment was more of a comment, and I didn't really hear a question. Can you restate your first question, please?
Who are you asking?
Jeff. I thought you had you said that you had a question.
No, I'm intrigued by your naming conventions. I'll be blunt, because I still haven't heard, how did Hilleman become the name?
Oh, so
how did Predico become the name? And that I'm honored to be a dilettante around the edges of VistA.
Hilleman, the guy who invented the mumps vaccine was named Maurice Hilleman, and so he cured mumps. We thought we were being clever, and his name is Hilleman.
I love it.
So that's where that name comes from. Predico means something. I can probably Google it real quick, but Predico actually means something in Latin.
It's out of the Greek somewhere.
Yep, that sounds right.
Predictive?
To make known, I think.
There you go.
Yeah. So that's where that.
All right, Joe. I have a question from Mike Henderson.
Who you?
Do the REST feature use HL7 Fire? And is there any plan to use Fire?
Currently, no, it does not. I have looked at that a couple times, and so we are kind of continuing the development, but because we don't have any external customers right now, really we're the only customers of the services that I'm developing. Even though that's not how we want it to be, of course. Obviously, I'm giving this presentation. There hasn't been a need to standardize that interface. So I guess the answer is I've looked at it, I've thought about it a couple times, but that's pretty much where it's ended, just because the need hasn't been there. I don't foresee any issues with that. It's just the model. There's not a huge amount of code that has, that's making its way up to the service right now. There's maybe a dozen scheduling service calls, a half dozen calls for you know, like user management, maybe more. But you would just, you know, make those into that that Fire spec. So I don't think that it would be a huge undertaking.
Mike, if you have any follow-on questions, I have to unmute your line if you have any questions, additional questions.
I do not, thanks.
Joel, in the meantime, could you go to the last slide? We have some information about our upcoming summit, just so people can see that while we're answering questions.
There it is.
Thank you. Great. And so we do still have about 10 minutes left on the line for anybody else with questions. Meanwhile, since we did move to this slide, I just want to point out that our annual event is coming up here at the end of June. And so we have about 100 different speakers and presentations, poster presentations, a lot of plenary speakers. And so there's a lot of interest here for the 3 days that we're having the event. And also, it's a really great opportunity to highlight your company and your work through sponsorship, exhibiting, and advertising. So please let us know if you have any interest there, and make sure to register before the end of May to get the discounted rate. And we will stay on for any more questions.
Yeah, and you would be the principal point of contact for that, correct?
Yes, I am.
Just thought I'd mention that in passing for Joel.
Joe, this is Peter. I do have a question. Do you currently your Project Hilleman interface is going through one instance, one VistA instance, right? It's not federated query, right?
So we have the capability to talk to, so there's, I think I highlighted, we're just real briefly though, there's a couple of different ways of talking to VistA. One of the ways is the RPC broker, because those FileMan APIs are available via the RPC broker. So we can talk to any VistA system that has the RPC broker, and actually, you know, that screenshot that I showed where we were pulling appointment data from a production VA VistA system into that UI, you know, that of course came through there. As far as federation, to add a new site, it's just, you know, it's all configuration file driven. If you want a new site, you just put it in the, I call it the source system table, and then, you know, you can talk to it. You configure, there's a number of different ways that you can configure Hilleman to work. You can configure it to run as an application account, so you can create a service account out of VistA facility and have Hilleman run as that service account. And, you know, that's kind of, I think, more in line with like a traditional database design model, you know, where you have a connection string that has your credentials in it, and you connect with that. And you know, you don't give your users any database access, you know, to get data in and out of the database. You handle that elsewhere. You know, you have a user table or something, and you do your checks somewhere else. So that's a model. It also supports, and it does all of these kind of simultaneously. There is like a pseudo stateless model where you can, we've developed some additional capabilities so that you can actually reuse connections. You can have a connection pool that is shared, but when a user is done with, or when a client application, the user of that client application is done with a connection, it just gets returned back to the pool. And every time we take a connection out of the pool, we do some setup and teardown. So we restore the user's, whoever that end user is, we restore that user's symbol table in VistA, and then the next time, you know, somebody else comes along and uses that same connection or another connection in that pool, we did the same thing. And then we also support a completely stateful model, which for anybody who's familiar with Meadows and some of the more technical fine points of it, that was the way that it worked. There was a connection that was open, you know, that Meadows held on to for the end user, and there was a a one-to-one mapping there. So I think that not sure if I actually answered your question. The federation, I guess, where I was going with that, when I think about federated, user management and, federated data access, I think of centralizing that someplace. So, having a centralized repository of all of your users, all their permissions, all that sort of stuff, and then, you just make calls. You use Hilleman in a completely stateless model, where it runs as a service account and or an application account in VistA, and you get data out that way, and you do user management elsewhere. So I think it kind of supports it. It doesn't really take a hard line on exactly how it should be supported. That's, I guess, it's a more succinct way of stating this is that that is also one of the areas that I have a little bit of interest in. I think that causes a lot of issues with VistA development today. Is the security model is pretty old, and it breaks down a lot. So being able to perform security, of course, still, but equivalent security, but doing it outside of VistA.
All right, I have another question from Mark Rose. I've muted your line. Could you speak up your questions? Mark?
Yeah?
Yeah, go ahead. Do you have some questions?
Oh, I can just go read them off. Okay. 1 second here. So how will the workflow process integrate with World VistA's work advancing VistA functionality? Can traditional experts still modify and extend the 6-month distribution and have that still easily integrate with production VistA? What's the process for modifying procedures in a hospital or clinic? So you were saying that it takes a year, but I had heard that now the doctor or technician drafts code and the on-site administrator makes it work with the existing code, and that's a fast turnaround. And then the slower thing might be that a national committee vets for general release into the entire distro.
So yes, a big part of the process is the process. It takes a long time to move things, especially in VA. Of course, this probably isn't so much the case in smaller VistA installations, elsewhere that aren't VA. But
what about the on-site? So, I mean, isn't the on-site modification a faster turnaround because it doesn't have to be the on-site? Each hospital or each clinic can have its own variation, and then when they roll that out nationally, that's what takes the time.
So, it's subjective, sure. I personally am of the opinion that that VistA, that it's too server heavy. There's too much stuff in months. And I think that the reason that there's so much stuff in months is because there were a lot of people, in the last, 30 years or so that that could develop in it and could develop in it really rapidly. But there's not a lot of people that can do it today. I think that we've built up a lot of technical debt over the years. I think that there's way too much logic, way too many business rules embedded in this stuff that not very many people can understand, and that makes extending that capability difficult. So that's kind of where I'm coming from, I guess. When I say, I think that it's a better decision to do it someplace that isn't, in months. The tools are better. It's a lot easier, I think, to find a C# developer than it is a months developer. It's a lot easier to find somebody that knows how to use Visual Studio or Eclipse than it is, whatever, and the tools there are that you can write M code in. I know there's some Eclipse plugins and stuff like that. But there's unit testing, and there's just a lot more tool-wise that I think in the end makes the costs lower to use more modern frameworks, more modern technologies. So yes, I think on some levels, if you have good MUMPS developers, if your guys know how to do that type of stuff, it absolutely can be quicker, maybe quicker to do it that way. But at the same time, I think that, like I said in the beginning, I think part of this conversation is about, not doing the status quo, trying something different, really taking a hard look at what some of this technical debt is, what it's comprised of, and looking at new solutions for addressing those issues.
There's an opportunity for rolling VistA, which World VistA was formed to do, to roll out VistA globally, especially in the developing world, where they don't have those trained people in the various modern systems. So my understanding is that it's easy to get entry-level VistA skills, and that if you have the people who've been in the VA working in support of them, perhaps remotely, perhaps on-site, that you could then take that out and do a lot. You could build up a lot of systems. You could also repurpose VistA for other functions of a city or a town or something. And so will the direction you're taking VistA in make it still easy for people to keep integrating back and forth with the medical stuff that happens at the VA and the research changes and the improvements that people who are now outside the VA make, or in World VistA make, on that 6-month release? Is this flow back and forth going to be supported technically in the way that you're looking to redesign it?
So I do think that there's definitely some room for some coexistence. I'm not in any way saying that all MUMPS development should stop. I think that that's probably a pretty silly claim to make. So I do think that you can support them both at the same time. I don't think that I would advocate for the cross-pollination, where you make some new functionality in MUMPS, but then you also make that equivalent functionality, that new functionality in something like Hilleman or Hilleman. I would say make a technology choice, but there's no reason, I don't think, that they can't live together. And that's part of the design. Is that new capabilities can coexist with old capabilities, but also other new capabilities.
Yeah. This is Jack Taylor. I'm going to put my 2 bits worth in before Peter does, is that when he talks about federation, he's talking about something different than when I talk about federation. What I'm talking about is OSEHRA, and some of the principles in OSEHRA is that the more contributions we get from people that are doing demonstrably effective work that come into open source, even with their proprietary components, then to Mr. Brooks' comment, that's where all this actually can come together, where what has never been agile can become agile, because it's back to the original principles of VistA, where it was a developer sitting down writing code next to a dock. But now it's advanced as VistA is attempting to advance through VistA evolution after 35 years to something that is coalescing around a series of standards and kind of the world's largest sandbox, whether it's World VistA or anybody else's version of VistA or DSS or whomever, is that there's room for everybody to contribute, play, and advance. There's my soapbox.
All right, it's already 2 after 4. Do you want to end?
Yes, so thank you again, everyone, for joining us, and we look forward to seeing you at our webinar next month. They're always the third Tuesday of every month, and we hope to have you join us at the summit, both as attendees and as sponsors. Thank you.
Thank you, Joel.
Yep, thank you. Bye.